Hey guys, welcome back. This will be the first video for the new semester. We're kicking it off pretty hard. This is going to be covering something called compound stoichiometry. That's how you pronounce that big ugly word. We got two good definitions here. The top one, the study of the quantitative aspects of chemical reactions. Remember, quantitative numbers. We're going to be dealing with a lot of numbers, a lot of math. The bottom one, stoichiometry, the art of counting without counting, the art of weighing without weighing. We're going to find masses. We're going to find number of atoms just by doing math. It's going to be pretty simple, but it takes a lot of practice. So the first thing we need to do is cover some basic vocabulary words. So atomic mass, you've dealt with this one before. It's the mass used for elements. It's down the periodic table. You're going to be using the atomic mass a lot with these calculations. Second one, molecular mass, is mass used for covalent compounds, which means formula mass will be for ionic compounds. And molar mass is a general umbrella term we use for all of these, but something that you should already be aware of. Covalent is molecular, ionic is formula. Those are two big similarities that you're going to have to be familiar with because you're going to be going back and forth with those vocabulary terms a lot. So the first thing we're going to talk about is finding molar mass. Make sure you mark this video if you don't get it, because you're going to have to find molar mass a lot over the next couple weeks. So step one is write the correct formula for the compound. If you don't have the correct formula for the compound, everything is going to be wrong. So always double check to make sure you've got your charges crisscrossed and all that good stuff before you go on. Next, you round the atomic mass found on the periodic table, each element to 2 decimal places. That means if we're dealing with carbon, carbon would be 12.01. Those last 2 decimal places is what we need. Make sure you round correctly. Number 3, multiply the rounded average atomic mass by each element, by the number of atoms, which means a subscript. So you're going to multiply atomic masses by the number of elements you have, and then you're going to add up all of those. Number 4, add the total rounded masses of all the elements. Great. So let's go ahead and put this into work. So find the formula mass for calcium phosphate. Make a small pen. Okay, so calcium phosphate, just for a little refresher, Ca has a +2 charge, phosphate, and the whole thing has a -3 charge. So remember, you crisscross those charges, you get Ca3PO4 2. So there's our step one. Step 2, you got to round the atomic masses. I'm going to do this kind of all at once so you kind of see how it works. But I like to count my atoms first. So if I go with calcium, why is this not working? Okay, well, pen change color. If I go with calcium, calcium's going to have 3 elements. And if you look at the atomic mass for calcium, which is going to be right here, it's going to be 40.08. I'm going to multiply that by its atomic mass, 40.08. The next element is phosphorus. Now remember, the 2 on the outside is going to go multiplied by whatever the subscript is on the inside. So we have 2 phosphorus atoms times its atomic mass, which is way over here, and that's going to be 30.97. Then you got oxygen. So oxygen is going to be 4 from the inside times a 2 on the outside. So you're going to have 8 oxygens. There are oxygens right here. That rounds to 16.00. So now I'm going to do those math problems. And I cheated, I went ahead and did these beforehand. I'll get this out of the way. And calcium gets us 120.24. Phosphorus gets us 61.94. And oxygen gives us 128.00. So now, you sum up all of that. You add up all the masses for each individual atom. That will give you 310.18 or 0.18 grams per mole. And that will be your answer. So it looks like a lot of work. Eventually, you're going to do enough of these in class that you'll be able to do this in your head and in your calculator real quick. Let's do a couple more practice problems. Oh, don't need that. So the next one, here's your polyatomic ion list in case you forgot. Ammonium sulfate, NH4, 2 SO4. Remember to crisscross appropriately. So nitrogen, we have 2 nitrogens. Look on the periodic table. Nitrogen is 14.01. It's going to be right here. Next element is hydrogen. 4 times 2 is going to be 8. Hydrogen's right here, so it's times 1.01. Next element is sulfur, of which we have 1. Sulfur is right here. That was 32.07. Then we have oxygen with 4 times at 16.00. So then you do those math problems. Like I said, I cheated again. So nitrogen gives us 28.02. Hydrogen gives us 8.08. Sulfur gives us 32.07. And oxygen gives us 64.00. So then we add all that up, and we get 132.17 grams per mole. Units are a big deal in this chapter, in this unit, so make sure you're paying attention to those. And our last example, dichlorine heptoxide. Keep in mind, now we're doing the molecular formula, molecular mass. Dichlorine is Cl, 2, di means 2, oxide is O, hepta means 7, Cl2O7. So chlorine, we have 2 of those. Chlorine's way over here, times 35.45. Oxygen, we have 7 of those, and we should be familiar with oxygen being 16.00. Do those math problems, and you get 70.9. And oxygen gives us 112.00. Add those up, you get 182.90 grams per mole. So that's it, pretty easy. There's never really any tricks. So if you got questions, write them down. And that's it for molar mass.